Okay, today we're going to talk about graphs of sine and cosine with horizontal changes, so both period changes, which we know as a horizontal stretch or shrink, or a horizontal shift. We'll start with horizontal stretches and shrinks. We know that if we have sine of b theta or cosine of b theta, then b will affect the horizontal stretch or shrink of the graph. And so we're going to do it in terms of the period, because the period, that when we think of trig functions, the period is really the amount of time for one revolution. And so it is a x kind of set of values that we use. So if we have sine of b theta or cosine of b theta, we're going to see a period change. And to figure our new period, we're going to take our current period, which is 2 pi, and divide it by whatever our b value is, and that will give us our new value. So let's look at an example. Okay. So I have an example here that involves several different types of transformations, and so I'm going to do my analysis first. I'm going to identify if I have any vertical stretches or shrink, my amplitude, period, and midline, and then I'll start my graph. And so I see a negative out here, which I know means that I'm going to have a vertical letting me do it darn thing. See that I have a negative out front, so I know that that's going to be a vertical reflection, reflecting around the x-axis. My amplitude, there is no amplitude change, so it's still 1. The amplitude is always positive, even if there's a negative out front, because the negative just implies the reflection. I see my b multiplier there, that pi over 4, so I know that's going to give me a period change. And my new period is going to be 2 pi divided by pi over 4, so divided by my b value. And I know that dividing by pi over 4 is the same as multiplying by 4 over pi, so I can kind of simplify that out as 2 pi times 4 over pi. My pi's cancel, and my new period is 8, so it doesn't involve pi, which is kind of unusual. Okay. My midline is going to be affected by that vertical shift of +2 out there, so my new midline is going to be y equals 2. And then I'm going to start to graph it. So in order to graph it, I'm going to deal with my midline and amplitude first. So I have a midline at y equals 2. I'm going to dot that in. Then my amplitude is 1, which means I'm going to go down 1 and up 1 from my midline. Now I'm going to deal with my period. My period is 8 for one revolution. So that means that I need a tick mark every quarter of the way between 0 and 8. So that means that, and I'm just going to make a little note here, TM for tick mark. My tick marks are going to be 8 over 4, or 2 units apart. So I'm going to start at 0 and end at 8, and then I'm going to have a tick mark every 2 units. So between 0 and 2, 2 away from there is 4, 2 away from there is 6, and then 2 away from there is 8. This is a graph of cosine. I know that cosine starts at its amplitude, and since the negative is there, normally cosine would start at its maximum, but because I have the negative out front, it's going to start at the reflected value, so it's going to start at its minimum at 0, and then go to its midline, and then up to its maximum, and then back to the midline, and then back to the minimum. And so I'm going to have a graph that my scale is not really well drawn there, but I should start at 0, be at the midline at 2, be at the maximum at 4, back to the midline at 6, and down to the minimum at 8. It should be more evenly spaced than that, but you get the idea. This axis, the x-axis, is still theta. Theta is my input value in all of these trig functions, and the axis here is just the y-axis. So this is just a small drawing of a positive x and then a y-axis. So that's still 0, 0. It's just a convenient way to lay out a trig function. Okay, let's talk about horizontal shifts. It's our last transformation. So we know that horizontal shifts have to do with adding a constant inside the function. And so we know that h in that case is going to be a horizontal shift. Sometimes in trig language it may be called a phase shift. You may see that language. We'll stick with horizontal shift because we've studied them that way and there's no need to introduce new language, but if you see phase shift, that's what that would mean. And remember that if h is greater than 0, my shift is to the left. If h is less than 0, my shift is to the right. Okay, let's do an example of one of those. So I chose an example that had a whole lot of things going on in it so that you could see the full process and what all the transformations would do. So in this case, there's no reflection. I like to do my analysis first, so I'm going to list my amplitude, period, phase shift, and tick marks first. So my amplitude is 3. It's the coefficient on sine. My period is 2 pi divided by my b value, so divided by pi over 4. I just did that. It's going to make my period 8. My horizontal shift is right 1. And my vertical shift, or midline, my new midline, is y equals -2. And then I'm going to add one more thing to my analysis here, and I'm going to think about how far apart my tick marks will be. So my tick mark placement is always my period divided by 4. So my tick marks are going to be 2 units apart. Okay. So again, I'm going to deal with my vertical information first, and then I'll deal with my horizontal information. So my midline's at -2, so I'm going to go ahead and plot my midline in, just dot it in right there. I have a vertical shift of an amplitude of 3, which means that from the midline, my maximum is going to be up 3, 1, 2, 3. So here 1, and down 3, 1, 2, 3. So down here at -5. Then I'm going to work on my horizontal information. I have a horizontal shift of right 1, so I'm going to go ahead and plot that horizontal shift. My period is 8, which means I do 1 revolution in 8 units. Since I'm starting at 1, 8 units away would be at 9. I'm going to start at 1 and stop at 9. And my tick marks are 2 units apart. So that means I'll start at 1, I'll have another tick mark at 3, another tick mark at 5, another tick mark at 7, and then the one at 9. Okay, so now I'm going to graph it. I'm going to try to graph it in a different color if the computer will let me, so let's try this. See what happens. It's sine. Sine starts at its midline, and it's going to start at the midline at that horizontal shift. So the horizontal shift kind of moves the starting place to the right 1. And so I'm going to start sine there, right 1. And then sine goes to to its maximum. So at 3, 1, back to the midline, back down to its minimum, and back to the midline. So my graph is going to look something like that. All right, that's it. Give it a try if you'd like. If not, we'll talk about it in class tomorrow, and you may choose whether you would like to take your quiz this week or whether you would rather wait till next week. But this way you have the choice. Thanks. See you tomorrow.